Now, what we're going to do first is that last question from the homework. What was the ID number on that one, Zach? 169? This is a really tough question. How many, there were three, weren't there?
No, true.
Oh.
1 and 8, true.
Oh, no, what I mean is, there were three point charges.
Oh,
Yeah, well, I just want to draw the picture first. Is it like this? One up here, one here, and one here? Yeah, and it's equally spaced.
Yeah, 120
Yeah.
degrees.
And what are the charges?
Top one is 4 microcoulombs. And the others are 2 microcoulombs.
Are they all positive?
It just says microcoulombs, yeah.
I guess so, okay. Okay. And what's the first thing they asked for?
Determine the magnitude of the electric field strength at the center of the circle due to the 4 microcoulomb charge.
Oh, just due to the 4 first.
Yeah.
Okay. So the first thing they have us do actually is just forget about the other two guys and just look at the 4 microcoulomb and how strong is the field here.
Radius is 4.33 times 10 to
Okay, excellent. The radius is 4.33 times
10 to minus 2.
meters. Right, well, we know the formula, don't we? It's E equals 1 over 4 pi epsilon 0, 4 times 10 to the minus 6 over 4.33 times 10 to the minus 2 squared. So what do we get there?
1.91836
1.918.
times 10 to the 7.
It's a big number.
Yeah.
Newtons per coulomb. What's this now? Continue? Yeah. Now the next part, I'm sure, is what is the electric field strength due to all three of them. This is quite tricky, because what's going to happen is, if you remember the definition of electric field strength, E equals F over Q. There are, if you put a charge here, let's put a positive charge here, how many forces are acting on this right now? 3. And they're not working together. For example, this guy is going to be pushing it to the right, and this guy is going to be pushing it to the left, and this guy pushing down. So they don't combine and they don't add together to make a stronger field. In fact, some of them actually cancel each other out. Now, we can calculate this. Do you remember the definition of electric field strength? It's force per unit charge. So we imagine that we have a 1 coulomb charge here. Okay? If the charge is 1 coulomb, then what becomes the formula for E? It just becomes F. So it becomes the same thing basically then. Now, we already know what is the electric field strength due to this guy. Here it is here. It's 1.918 times 10 to the 7 newtons per coulomb. And how many coulombs do I have in the centre here? 1. So this becomes I'll just write 1.918, but don't forget there's the 10 to the 7 here. Okay. Now we could recalculate it for these two, but then quite quickly we realise we know the answer straight away. Because what is the only difference between the 4 and the 2 here? Is that yeah, that's it. So if you divide this number by 2, you can get it this direction. So what would that be? 0.
9.58.
Oh, sorry. 9.59
587.
then.
591.
And then 9.58. 59. Now those three forces, Well,
Times
that-
10 to the 6, though.
huh? Times 10 to the 7.
6.
Oh, okay. Oh, I'll write little 6s here to remind me, and this one I had a little 7. Okay, they don't work together. Some of them actually cancel. What you can see here is, if you resolve this one here and here, then what will happen with the left force? It will cancel the one here, won't it? So the only ones you're left with are these two and this one. So the total force
Is
per coulomb will equal 1.918 times 10 to the 7
minus
minus 2,
cos
9.59 times 10 to the 6 cos 60.
yeah.
Yeah, 620.
That's F per coulomb, but that's going to be the same thing as the E. So whatever you get here, that's the E as well. So what is this, please, on the calculator?
How did you get 60?
You told me 60.
3.7.
It's half of 120. I hope.
3.745 then times 10 to the 7. 745.
Yeah, so I've rounded
yeah,
up.
okay.
It's a very hard question. It really is very hard. Are you sure, Diego?
Well, that's what I wrote in the calculator.
Did you type it? Because I would have thought the answer should be smaller than 1.918 times 10 to the 7. Ah, no, I think he did something wrong, Diego. He's typing something wrong, surely.
Dude, I can't even
What is it,
understand
Gina?
why when you wrote writing like this.
I don't write it like that, it's a calculator that puts it like that. But that is, I copied this one, so it can't be wrong.
Are you in radian mode? That he's right. Impossible.
Is it plus 60?
I think it's cos 60. Yeah, it's half of 120.
No, sorry. I made a
What is
small
the
mistake.
answer?
Well, he was wrong. What is it?
9.5936 times 10 to the 6.
It's the same answer.
Like this, yeah?
Yeah.
Okay. Were you in radian mode? Oh, I did. Okay. Quite difficult, right? Quite
And
difficult.
its direction is
Oh, and the direction is
Downwards
down, yeah.
or towards.
Yeah, downwards, yeah. Away from the 4.
Away from it. Because you don't really have a.
Yeah, you don't have
There's
it
no
down.
down or up.
Away from the 4. What's wrong, Zach? You're not looking happy with this. Are you still not happy with the 60?
no, that's fine.
Okay. Then what? What is it, man? Speak to me.
I don't know. It just
What?
something doesn't feel.
Well, they can. Do you want to check the answer?
Guess I can do that. 13, 14.
So it's easy to see that it's gonna go away from the 4, but then calculating it.
It's quite tricky, yeah. I think that's fine.
Okay.
I think it's fine.
Because if one is positive and the other ones are, what is it? The opposite?
The arrows would get flipped around, yeah. Did you find the answer, Zach?
Yeah. Yeah, 9.5 6.
Okay. So I guess I can continue teaching then. I know mostly what I'm doing. It's very difficult. And how many marks was it? Like 3?
Oh, I closed it. Let me see.
You know all that.
Well, I don't know.
Ah, I closed it.
It doesn't matter. It was a section A question, so it
Yeah.
can't be that many. Right, we'll continue with the next lesson. Which is magnetic fields now. Is that the door? No. Okay. I think I'll get to do. I think this is big enough. Yes, I'll have to split this up into 2 parts.